Welcome to today's webinar. Our monthly webinar about the FAQs, most frequently asked questions answered by Dlubal support team. It will take about 30 minutes, I think. My name is Andreas Hörold. I am responsible for marketing and public relations in the company Dlubal Software. For instance, the Dlubal website, German and English webinars, customer projects, and so on. I've been working for the company Dlubal Software for 12 years. I will be the moderator and presenter today, and I will be supported by Markus, but he can introduce himself.
Hello, my name is Markus Baumgartel. I'm responsible for customer support and frequently asked questions on our website. And today I will help my colleague Andreas to answer your questions during this webinar.
Okay, thank you
Thanks.
for the introduction. Then we switch off our webcams that the attendees can see the full screen. For the attendees who participate such a webinar the first time, you can show or hide the control panel with that arrow here. And then if you have a question, you can enter the question here and Markus will answer you. If there are too many questions and he can't answer during the webinar, you will get an email afterwards. The other way is to watch the entire webinar and then email questions to info@dlubal.com. Okay, then I turn to the program RFM6 and I read the first question. The first question is, how can I quickly check the quality of the FE mesh for my surface model? At first, we create the FE mesh, or we generate and display the FE mesh. The display of the FE mesh quality helps calculating structural components consisting of surfaces. And when generating the mesh, an internal check of the created FE elements is performed according to certain criteria. And you can display the results graphically. You have to open the navigator display. Then you search the mesh here, mesh. And then you have to check the FE mesh quality. There are 3 levels shown in green, yellow, or red. Green is okay, yellow warning, and red failed. And you can see there are 64%, 64% of the FE mesh or of the FE elements are okay. 24% were warning and 12% fail. Okay, you can see on purpose I created a very large FE mesh to get such failed elements. You can see here, or you can go to the navigator display and only display the criterion failed. And you can see the ratio between the width and the height is too large, and that's why the FE mesh or FE elements failed. So we go back here above, to the mesh settings, and with that table here, or with the table, you can as the values of the criteria to be checked can be adjusted. For example, the criterion, the aspect ratio, and so on. I would leave the default settings, but it would be possible to change those settings. So, and we go to, and you can also see the percent values here on the right side. to avoid such failed FE elements, you can add FE mesh refinements, or you can define a smaller FE mesh. I will do that. I create an FE mesh with a size of 10 centimeters. Press OK and apply. And you can see now it's quite okay. No failed elements, and the most are okay. Yeah, it cannot replace the engineering check of DFE mesh by the user, but this tool is quite a good help to detect such failed elements and so on. Okay, yeah, that's all to this question. I turn to the next model. And the next question is, I see gaps in the numbering of my load cases. How can I cancel this incomplete numbering? Let's take a look here at the load cases and combinations in the table. Okay, and you see now there's a small gap, but sometimes there are a larger gap. Of course, you can click on such a line and then delete the row and the next and so on. But if there is a large gap, you can use this tool, above tools, renumber and shift. So, and where are the load cases and actions and so on. And to cancel such gaps, you can click on load cases and then here 9 to 16 and increment -1 and then apply. Okay, that's all. Yeah, it's a quite good help or to cancel such gaps. Okay, that's all to this question. The next question is, why are my geospecific parameters not transferred to the load wizard? You can use the geozone tool for the load wizard on here left above under the base data and model parameters. You can select a certain place. And if a location is selected in the geozone tool, the location specific parameters are also passed on the load wizard. Yeah, I will show you how to do that. I select a location. I use the location of our main office in Germany. Okay. And you get the snow load zone and the characteristic snow load, the wind loads and the seismic loads. And if I press OK, all the values will be important in the program. So it takes a moment. Right. Outside the map. Oh, where's an arrow? I try our location in Leipzig, Germany. Okay, I don't know what was the problem. Actually, it should work. Okay, and now the location is transferred and the values for snow and wind and also the seismic loads. I press OK, and then I go to the load wizard, insert, left above, insert, load wizards, and I try the snow load wizard. Okay. And you can see the snow load is not transferred to the load wizard. That's the default setting. And that's the problem. And in that case, the problem is, I go back to the base data, and under standards, I leave the standard national annex for the Eurocode, and I have to check Germany here because I selected a location in Germany, and that's why I have to select the German national annex here. Yeah, and that's also valid for your location in Europe or in another country. Okay, and now it should work. Insert load wizard, snow load wizard, and so on. Okay, and now you can see the location is imported and the load zone and the altitude and the characteristic snow load. Okay, yeah, that's all to that FAQ question. We turn to the next question. We stay on this model. And the question is how to superimpose imperfection load cases only with unfavorably acting wind load cases in order to avoid unnecessary load combinations. Okay, at the moment, all load combinations consider the different imperfections. I create only 2 imperfections, but all the 240 load combinations contains those imperfections. Let me search the combination number 60. And I show also the imperfections. Yeah, and you can see that load combination consider the wind load in plus X direction and the imperfection in minus X direction. Yeah, and that makes no sense. How to avoid that? On the left side, you see the navigated data and the imperfections and the imperfection cases. 2 imperfection cases. I double click on the first and I assign the imperfection in plus X direction to the wind load cases, the 2 wind load cases in plus X direction. In plus X direction, that was correct. And the imperfection in minus X direction, for this imperfection, I assign the load cases in minus X direction, the wind load case in minus X direction. So, okay, we apply that. So, and then we go to the load combinations. And there are only 184 load combinations, not 240 as before. Okay, that's also all to this question. I turn to the next model and the next question. So the next question is, my model becomes unstable when being calculated according to second order analysis. How can I find out if my wind bracings are the reason for it? Let's calculate the design situation. In the current model, the bracings are defined by trusses. You can see it already. The model becomes unstable when it's calculated. You can see the error messages here. And how to avoid that? I described the problem. The problem is there are only load cases with loads in plus Z direction, the self-weight and post load, and the snow load. And if you have trusses for the diagonals here, around 20 is that diagonal here. Yeah, and they get pressure because of the load in plus Z direction and fall out. Yeah, and then there are no diagonals anymore, and the model becomes unstable. So in the first step, I select all the diagonals and double click on it. So, and I change the member type to tension. Yeah, and if you select the member type tension or cable, then there are the reactivation tab appear in the static analysis settings. I will show that. So I select tension. Okay. So, and where to find the static calculation settings? There are two ways. And I show you two ways. So I go to the design situation, and where are the combination wizard? And if I press here that button, I see the used static analysis setting. This is the default static analysis setting, second order analysis for such, for the load combinations and the design situation. So, and if I press the right button again, you can see the reactivation dialog here. So I cancel that to show you the other way. Here on the left side, navigator data, you can see the static analysis settings, and I double click on this one, and you can see the reactivation the dialog. So, and there are different options. For example, the exceptional handling, failing members to be removed individually during successive iterations, or assign reduced stiffness to failing members. And you can, enter a reduction factor of the stiffness here. And then there are a small stiffness for the tension member, for example. And as I already said, this table or this dialog, you have only this dialog when you use tension or cable members. Okay, and in the main dialog, I enter or I increase the number of load increments, and I calculate all again. So now the model should be stable. Okay, we get results. All is fine now. Okay, then we turn to the last model and the last question. The last question is, how can I define the yield strengths of material, for example, steel, depending on the structural components thickness? I created 4 cantilever beams with different cross sections. You can see here that is a flat with thickness of 10 millimeters. You can see it also in the control panel. This one has a thickness of 17 millimeters, or a width of 17 millimeters. This one is 41 millimeter, and this one is 151 millimeters thick. Okay, I already defined the material, steel material. I do that again. I open the material library, region, for example, European Union, steel. And if I select the steel S235 GR, then you can see in the material values where are different yield strengths defined for the different thicknesses. 16 for the 60 millimeters thickness, or the maximum thickness 60 millimeters is the yield strength 235 Newton per square millimeter. Okay, and those are the other thicknesses and the matched yield strength. And if you want to modify those values, then you have to check user-defined material here, and then you can modify the yield strength and thickness and so on. If you have a certain material and it is necessary, then you can do that, and you can also define or modify the stiffness. Okay, I press OK. And we would like to do a stress analysis. That's why I go to the base data and activate the add-on stress strain analysis. Okay. I have to go to the design situation, and the stress strain analysis is already activated. It's not necessary to activate it for those design situations, only for the ultimate limit state design in this example. Okay. Then in the table at the bottom, I select the stress strain analysis and calculate all. Okay, then I select the stresses on members and define stresses by member, for example. And now you can see the different stresses and here the different limit stresses for the different thicknesses. Okay, that's all for this presentation. This was the last question. I only want to make a little bit advertising for our next webinars. Or at first I show you where you can find the recording if you want to see the recording and use the provided models. Under news and events, you find the, it's in German, sorry, I have to select English. News and events, webinars. And that's today's webinar. I click on it. In the next days, you will get an email with your certificate, with your attendee certificate, and then you will see the recording here. And we already uploaded the models here. Okay, and if we turn back to the webinars, as a news and events, webinars, then you can see the upcoming webinars. And in the next week, we present our new add-on or our new feature in the timber design, the design of CLT panels. That's a quite new feature. Then also on the same day, it's in American time, the reinforced concrete tank design. Then 1 week later, the stability and warping torsion analysis in AFM6 and RSTARP 9. Masonry design 1 week later. And those are the planned webinars in the next time. We usually present one webinar for in 1 week. Mostly in German on Tuesday and in English on Thursday. Okay, if you haven't used our software and you want to try the trial version, then just download it from our website and use, for example, the webinars and provide models for exercising. Okay, that's all for today's webinar. When you leave the webinar, there's a small survey. It would be nice when you answer some question, or you must not, or you don't have to answer the questions, but you can score us. Just note that the worst score is 1 and the best score is 5. I think it would take only 1 minute or so. That would be nice. Okay. Then that's all for today's webinar. I thank you for your attention. Thanks to Markus for answering the questions. I wish all a nice rest of the day, and I hope to meet you in another webinar, maybe in the next time. Okay, bye-bye.